Earth is home, a small, bright world wrapped in a thin skin of air, drifting through a darkness so large it barely makes sense. Every person you have ever known, every city ever built, every victory and mistake, every song, every war, every love story, all of it happened on this one moving speck. And the strange thing is, we live as if this is the default, as if here is the center. So let's do something simple and also kind of dangerous to the ego. Let's zoom out, step by step, and watch familiar reality shrink until it becomes unrecognizable. We begin with the first distance that already breaks intuition, the moon. It's about 384,000 kilometers away. That number sounds ordinary until you imagine trying to cross it in anything built for human life. If you drove a car at a constant 100 kilometers per hour, no stops, no sleep, no refueling problems, it would still take more than 160 days to get there. Half a year of highway driving, just to reach the closest natural object in space. And from that distance, Earth stops looking like a world you live on. It becomes a sphere of color suspended in black. No borders, no labels, no evidence of the things we think are permanent. Just oceans, clouds, and the thin glow of atmosphere that tells you something fragile is clinging to the surface. Then we keep going. Next comes the sun, the object that dominates our lives so completely we forget it is actually far away. The average distance from Earth to the sun is 1 astronomical unit, about 150 million kilometers. That distance is so useful that astronomers turned it into a measuring stick for the entire solar system. Light, moving at roughly 300,000 kilometers per second, takes about 8 minutes and 20 seconds to cross it. So when you look at sunlight on your hand, you are touching the sun as it was more than 8 minutes ago. And if you tried to travel that distance in a commercial jet moving around 900 kilometers per hour, you would be in the air for about 19 years. 19 years. Not to another star, not to another galaxy, to the sun, the thing that feels like it's right there above you. And already the solar system begins to reveal what it really is. Not a neat set of neighbors, but a huge volume of emptiness with a few islands of matter scattered inside it. Now aim outward toward Mars. At its closest, Mars can be around 55 million kilometers away. At its farthest, when the planets are on opposite sides of the sun, it can be over 400 million kilometers away. So even the concept of distance to Mars is slippery. It changes constantly because everything is always moving. This is part of what makes interplanetary travel so difficult. You aren't driving to a fixed address. You're launching yourself into a moving clockwork and trying to arrive at the right spot at the right time. When we send spacecraft there, they take months, not because Mars is only tens of millions of kilometers away, but because you have to ride the geometry of orbits. Space travel is as much patience as it is power. Keep going, past the asteroid belt, past Jupiter's storms, past Saturn's rings, past Uranus, and eventually you reach Neptune, the last of the 8 major planets. Neptune sits roughly 4.5 billion kilometers from Earth. Sunlight takes a little over 4 hours to reach it. That means if the sun vanished, Neptune would keep shining in daylight for hours before darkness arrived. This is the edge of the solar system in the way most people imagine it. The last planet, the final stop. But Neptune is not the end of the sun's domain. Not even close, because out beyond Neptune is where the solar system becomes less like a family of planets and more like a graveyard of leftovers. And out there, one object has been quietly proving just how enormous this space is. Voyager 1. Voyager 1 was launched in 1977, and it has been traveling outward for decades, moving faster than any other human-made object relative to the sun. According to NASA's live tracking, it is now over 171 astronomical units from Earth, more than 15.9 billion miles away. NASA science. It is so far that far stops being a useful word. In 1990, Voyager 1 turned its camera back one last time and took a photograph of Earth from about 6 billion kilometers away. The image became famous because Earth was not centered. It wasn't highlighted. It wasn't dramatic. It was a tiny point caught in a beam of scattered light, a pale dot. And if you stare at that dot long enough, something uncomfortable happens. You realize that everything you take seriously, everything you worry about, every argument and ambition is happening on something that can be hidden behind a pixel. But Voyager 1 is still nowhere near the true outer boundary of the solar system. To reach that, we have to go farther out, into a region that is still partly theoretical and partly inferred from the behavior of comets. The Oort cloud. The Oort cloud is thought to be a vast halo of icy bodies surrounding the solar system, and NASA estimates its outer edge around 100,000 astronomical units from the Sun. NASA science. That's a number so large it changes the meaning of solar system. At 100,000 AU, you are talking about distances on the scale of light years. You are approaching the realm where the gravity of other stars begins to matter, where the Sun's influence thins and the galaxy begins to tug back. Somewhere out there is the heliopause, the boundary where the solar wind finally loses its fight against interstellar space. Past that line, you are no longer inside the Sun's protective bubble. You are in the raw medium between stars. And now, the measuring stick changes again. Astronomical units stop being practical. So we switch to light years, the distance light travels in 1 year. The closest star system to us is Alpha Centauri, about 435 to 4.4 light-years away, tens of trillions of kilometers. Imagine gsfc.nasa.gov. That distance is the kind that makes you laugh if you try to imagine it as a road trip. Voyager 1, moving at around 17 kilometers per second, would need tens of thousands of years to reach even the nearest stars. Not because our engineers lack courage, but because the universe is built on distances that do not care about the human timescale. Now widen the frame again. Our star is one of hundreds of billions in the Milky Way, a spiral galaxy roughly 100,000 light-years across. Imagine .gsfc.nasa.gov. That number is so large it's hard to feel it. So let's translate it into a different idea. Humanity has created a bubble in space, not of ships or probes, but of information. For about a century, we have been leaking radio and television signals into the cosmos. Those signals travel at the speed of light, so they have now spread outward into a rough sphere about 100 light-years in radius. That's it. A small, thin bubble inside a galaxy that is 100,000 light-years wide. Meaning that if there are civilizations elsewhere in the Milky Way, almost all of them would have no clue we exist yet. Our entire broadcast history, our wars, our music, our voices are still trapped in a tiny neighborhood. Beyond it, the Milky Way remains silent about us. And now, leave the Milky Way entirely. You enter intergalactic space, a place that isn't empty in the absolute sense, but feels empty in the human sense. Here, galaxies are islands separated by distances so huge that even light needs millions of years to travel between them. Our galaxy belongs to a small community called the Local Group, which includes dozens of galaxies, with the Milky Way and Andromeda as the two giants. Go farther, and the structure becomes less like scattered islands and more like a web. Galaxies gather into clusters. Clusters join into superclusters. Superclusters form filaments. Between them are voids, vast regions with comparatively little matter. On this scale, the universe starts to look like a cosmic nervous system, a tangled network stretching in all directions. One of the large structures associated with our region is the Virgo supercluster, a massive arrangement of galaxy groups and clusters spanning on the order of 100 million light-years. Wikipedia. Then you zoom out again and Virgo itself becomes part of something even bigger, a vast basin of galaxies known as Laniakea, defined in 2014 as a larger gravitational region that includes our home group, Wikipedia. At the heart of this region lies the Great Attractor, a gravitational focal area that many nearby galaxies, including ours, appear to be moving toward. Not because it is magical, but because mass shapes motion on every scale. This is one of the strangest feelings in astronomy. Realizing that your galaxy is not just drifting randomly, but participating in a slow, colossal migration you will never experience directly. A motion measured not in minutes or years, but in hundreds of millions of years. And now we reach the edge of what we can actually see. The observable universe. The universe is about 13.8 billion years old, but the observable universe is much larger than 13.8 billion light-years across. Its diameter is about 93 billion light-years. Wikipedia. That sounds like a contradiction until you remember something that's easy to say and hard to truly grasp. Space expands. Light has been traveling for 13.8 billion years, but while it traveled, the space it moved through expanded. So the galaxies that emitted the earliest light we can see are now much farther away than 13.8 billion light-years in present-day distance. That's why the observable universe is so huge. And even observable is a warning label. It means there is a horizon, a limit set not by our technology, but by physics. Beyond it are regions whose light has not had time to reach us. And because expansion is accelerating, there are regions that may never be observable. Not now, not ever, no matter how long we wait, because the space between us and them grows too quickly. So what lies beyond the observable universe? We don't know. The true size of the entire universe may be vastly larger, perhaps unimaginably larger, and it could even be infinite in extent. Wikipedia. That's the final zoom out. Earth, once the whole stage, becomes a speck inside a speck inside a speck. And after all the numbers, after all the scales, after planets and probes and stars and galaxies, the most unsettling part is not how small we are. It's the realization that the universe does not end where our vision ends. There could be entire regions filled with galaxies, collisions, births of stars, dying worlds and civilizations that rise and vanish. All of it happening forever beyond our reach. Not because it's too far for a rocket, but because the fabric of space itself has placed it outside our causal future. So when you look up at the night sky, the real humbling truth is not that you're seeing space. You're seeing the part of reality that was allowed to reach you. And beyond that, the cosmic ocean continues into darkness, filled with pages of the universe's story that we may never read.